Hello everyone. Today, we will explore the DIY proof of concept project Smallest Wearable Smartphone published on electronicsforyou.com. The link to the project is in the description of this video. Smartphones play a crucial role in our daily lives, and we are enhancing their functionality by integrating smartwatch features into our compact devices. This innovation makes it easier to stay connected. Today, we will design a phone that measures only 3 centimeters long, much like a smartwatch. We'll break down the process into several simple parts for easier understanding. This is the first part of our project. Let's start by listing the main features. This device will support 2G and 4G SIM cards, connect to Wi-Fi, and perform essential phone tasks like making calls, sending messages, saving contacts, and accessing the speakerphone. Now that we have the basic features outlined, let's brainstorm some additional ideas that could enhance this phone. How about adding games, a calculator, and a feature to share contacts over Wi-Fi? Furthermore, incorporating Wi-Fi calling and a tool to help locate the phone could set it apart. These are great ideas. After we finalize the design, we can add more features if needed. Today, our focus will be on the basic appearance of the phone and testing its calling functionality. This project results in an extremely compact smartphone, roughly the size of a smartwatch, and it can operate on both 2G and 4G networks. Are you ready to discover how it works? Here, you can see our small smartphone, which handles all basic phone functions, including making calls. This project is ideal for gadget enthusiasts, individuals seeking a tiny phone, and those who enjoy customizing their devices. It's also perfect for students, providing a hands-on opportunity to learn about electronics and technology. So, how do we make it? You can assemble this device with just a few components. Let's take a look. The Indus board coin is the core component that runs this device. It was chosen for its compact size and multitasking capabilities. It includes built-in tools like a magnetometer, accelerometer, temperature sensor, and Wi-Fi, all within its tiny frame. The CST816 touch round display glass is the same size as the main module. It enables users to tap and swipe to control the device, making it user-friendly. The SIM800L GSM module allows the device to connect to cellular networks, enabling text messaging, making calls, and internet access over these networks. It's compact and energy efficient, making it perfect for a small device. We will also require a soldering iron, as some components in the project will need soldering. To assemble the circuit, follow the circuit diagram closely. First, solder a connector to the Indus board coin, which will connect to the touchscreen display. Both the display and the board are the same diameter, ensuring that our smartphone remains compact. Next, connect the GSM module. You can either assemble the GSM module on a breadboard and use jumper wires or solder the wires directly to the Indus board coin. Lastly, position the GSM module on the board in line to maintain the smartphone's small size. Additionally, we will connect a buzzer in this circuit in place of the speaker. Once the circuit is complete, we will write code for the Indus board coin using the Arduino IDE. We will start by programming the basic user interface to manage functions such as displaying numbers, answering calls, and sending messages. Next, we'll create the dial screen and keyboard UI for inputting letters and symbols. The GSM module connects to the Indus board coin via a serial connection, and we assign specific pins to facilitate this connection. The module utilizes common commands, known as AT commands, to perform actions such as volume adjustment, making calls, and checking network status. We use the GSM SIM library to streamline these tasks and ensure that the features operate smoothly. You can download the source code by clicking the link provided in the video description. Note that this is just the initial code for the project, allowing you to make calls and test the signal strength. After assembling the circuit and uploading the code, power up the Indus board coin. You can test the keypad UI by dialing a number. As you can see, it works. So, What did you learn today? How to build and solder a circuit. How to select and assemble very small components. How to design user-friendly screens that fit on compact displays. Interested in developing your own smallest wearable smartphone? Kindly click on the link provided in the description of this video. Do like, share and subscribe to our channel for more such DIY proof of concept videos. Thank you.